Welcome to another Fenestration Canada podcast.
And now it's technical time with UL.
Hello and welcome to Technical Time with UL, where we talk about the ongoings of the window and door industry and how we can enable safety and sustainability of your products. My name is Ryan Harper and I'm your host today. You may know UL for testing and certifying fire-safe products, systems and structures to withstand fire and other various testing programs. Joining me today, however, is Haya Sagrati, who is the manager of Toronto Laboratory Testing Services. And we're going to talk about how we provide a unique combination of services to assess and validate the design and performance of building envelope components, products, and systems. Thanks for joining me, Haya.
Thank you for inviting me, Ryan.
So Haya, let's, from a general overview perspective, how does UL help the building envelope industry?
Well, Ryan, through our services, we ensure building envelope products and systems meet regulatory demands and protect brand values. Manufacturers, consultants, architects, building owner, and regulatory authorities trust us for the knowledge and expertise we provide to the construction industry.
Right. Okay. We have got a really great team and a very experienced one at that. Many of them are recognized as industry leaders across the country. We operate, and these teams operate out of our centers of excellence in Toronto, Montreal, Chicago, and the UK. What services are we offering out of those laboratories?
Our labs offer a wide range of different testing services, including building envelope performance testing, fire testing, and also building forensic services and building system commissioning services. Depending on the services we require, we can test products and systems in the lab, or we can witness testing at the manufacturing facilities, or we can conduct on-site testing during and after installation. Our labs are capable of testing different products such as windows and doors, skylights, curtain walls, wall systems, full building envelope assemblies, and also guardrail systems.
Okay. When products are brought into UL for testing, what are they evaluated for?
Well, Ryan, our labs, which are recognized by many different industry organizations, provide performance testing to meet market regulatory and project specification requirements. We can evaluate the performance of the products based on air permeability, water permeability, water penetration resistance, wind load and structural resistance, thermal and condensation resistance, thermal and impact and pressure cycling, also thermal and hurricane resistance, and then also fire resistance and flame spread. To ensure products and systems meet many different industry standards such as Navs, CSA, AAMA, WDMA, NFRC, Miami-Dade, TAS, ICC, NFPA, UL, and ULC, or just to name a few of the standards we can test.
Well, that's a lot. Certainly. Well, again, thank you very much for your time today, giving a very brief overview of how we can help the industry. Thanks to you for joining us. If you'd like to learn more about UL services, please visit canada.ul.com/fencan. That's FENCAN. Or you can email Haya directly at haya.sagrati, SOGHRATI @ul.com. Thanks again.
Thank you for having me.
This podcast is a presentation of UL Inspiring Trust. This podcast is a presentation of Quax Building Products. For more than 30 years, Super Spacer Tri-Seal from Quax Building Products has been the ideal warm edge spacer solution for commercial and architectural glass. With its unique triple seal design, Tri-Seal provides structural strength, durability, and outstanding thermal performance in the most demanding applications. Learn more at quax.com. This is Tech Talks, live conversations about the regulatory environment with Al Yagalis.
So, welcome everyone for this third episode of the new season 2 of Tech Talks. I understand, Al, that today we have a special guest.
Yes, we do. I'm happy to introduce Tarek Elewa as the Assistant Test Manager at the UL Lab in Toronto, who also manages the UL Chicago Lab's Fenestration Department. Tarek has a lot of experience with testing fenestration products and also with the AAMA standard with respect to qualifying mullions and mullion assemblies. As a project engineer at UL, he's responsible for engineering analysis and calculations for fenestration products. And so we're happy you could be with us today, and we're looking forward to learning more about this. This is the third show in our series on mullion assemblies. Just to remind our listeners, mullion assemblies is a new product type that was introduced in the 2011 version of the Navs standard. And NAFS 11 allows us to qualify mullions not just by testing them as part of a window in the lab, but also to use the AAMA 450 standard. So last week on our show, we had Dave Goldsmith, who was an engineer with Flygem and Cornerstone brands, kind of talking about AAMA 450 from the manufacturer's point of view. Today, we'd like to learn about AAMA 450 from the test lab's point of view in terms of how that can help manufacturers to get the most value when they're qualifying mullions in the lab. So Tarek, I'm really looking forward to learning more about what you've got to say on this subject. So I'll turn it over to you right now.
Hi, Al. I'm really happy to be with you today. I'm a big fan of the show for sure. And,
thank you.
I learned a lot of things listening to the tech talks, and I'm very happy to be with you today. And I'll be happy to share a bit of my knowledge for AAMA 450 and try to help manufacturers and facilitate their lives in a way by understanding more this standard, understanding more their grouping, understanding what they can do and how they can use testing and calculation to minimize the amount of tests and pay less to get more products covered. It should be interesting.
Looking forward to it.
So I'll start by sharing some pictures. Dave last week showed a couple of pictures. He showed a very nice video from our facility. I couldn't find this video. I don't know how he found it, but he beat me to it. But yeah, I have a couple of pictures that I'll share with you, and I'll explain why we do this test and why mullions are very important to be tested and calculated. So Stefan, I'll be sharing my screen and
go ahead
with the pictures. So we'll start with this combination. As you can see, the bending in the middle. If you're sitting home and you see your window bending like that, you won't be happy for sure, and you will be actually scared to sit home. This is the product that Dave showed last week, and as you can see, the combination with the bending, same thing.
So Tarek, would these be reinforced or unreinforced mullions?
Well, these are unreinforced mullions, and as you can see, the deflection is huge. Even with reinforcement, depending on the design pressure for sure, it changes all the time. The deflection, the type of reinforcement give us different deflections. There's wood reinforcement, there is aluminum reinforcement, steel reinforcement. It depends on the manufacturers. Different steel reinforcement give us different design pressure and different deflections. So the majority of these ones are reinforced, are not reinforced, and that's why we see the huge deflection as we see here. Here, it wasn't the mullion specifically, it was the intersection of the horizontal mullion with the frame that caused the product to completely fail and the frame itself to fail, which is interesting. It's not just the mullion that can fail, it's also the product itself. The frame surrounding the product can fail, since this is considered the weak area in the product. This is another combination with a transom, a door, and a fix, and you see big deflection there. So yeah, the glass bends, everything bends, and it's like a balloon.
I think anyone with an engineering background, you look at that window and you say, that horizontal element, that big transom is going to be a problem, right?
Yeah. Well, you can always include and test it, and we will see that when you test the biggest size, it covers the smaller size.
Yes.
So if we get the value for the biggest size, even if it deflects like a lot, and it has, you see it like that, you can still have tables for R and LC classes. You don't.
Right.
We create the CW classes table for the same product, and we can also create the R and LC class tables. So you get both. Yes, you test a big product. Yes, it has a huge deflection like that, but by testing this product, which is a big product as we can see here, but it covers all the smaller sizes, which is very good, since you don't have to test each and every type of product or each and every size. With this combination, we'll cover that during the grouping for sure, but we can cover the horizontal mullion separately, and we can cover the product for the vertical mullion. So in the calculation, we take the deflection and everything from this test, and we transfer it as if the product was tested just with a vertical mullion. This way, you don't have to test a separate product. For sure, the deflection is higher when you have a transom, but you don't have to retest and do different testing. So I'll stop sharing, Stefan.
All good?
Yeah. So these are some of the pictures that we see a lot in the lab. There's for sure patio doors that bends a lot like that, and it's pretty interesting to see it and see how products and push the limit of the products. We usually go until failure just to make sure to know exactly the design pressure of the product, which is pretty interesting. It's a good thing to see, and it's a nice show for the client to watch. But it's pretty annoying to clean the glass when it breaks after. the annoying part for sure, but it's pretty good for the client to know the limits of their products, not just stop at a specific design pressure, because you never know when the product will break. Testing show you that for sure.
And I think that's one of the reasons that we test products, because especially with, you might say, the lighter weight products, the R and LC class products that don't have much reinforcing or sometimes no reinforcing, you can't really determine the strength of the product on the basis of engineering, right? Yeah. There are so many indeterminates. There's the deflection of members, how the glazing beads hold the glass. If the product deflects more than L over 175, then, as you say, you really don't know what the limit is, right? And so, and you also don't know what the weak point is. So sometimes you have a window that looks like it's very strong, but it fails in a joint, for example, or a glazing bead comes off, right? Mm-hmm. Other products look like they're balloons. You can blow them up and they just won't break, you know. So you know, there's, but the physical test actually shows you how the product performs under extreme conditions. And as you say, you know, understanding where the limit is. And if you test to failure, I think manufacturers can learn a lot by testing to failure. because then you learn where the weakest part of the product is. In some cases, it's something that you can fix relatively easily, by redesigning a connection part or something. In other cases, you can't. But I think one of the things that I know, I used to work for a manufacturer, is that you learned a lot about your product in the test lab, and that testing really can inform improvements in product design. But thanks for sharing those extreme conditions.
Thank you. And as you said, by testing, you can see the weakest point. It's maybe just a keeper that changing one keeper can make a big difference. Type of sealant. There's so many things in the recipe of the product that you putting it all together makes the product. So if you have one specific weakness, you will get to see it. You can modify it, adjust it to improve your product. And yeah, that's what we see every day in the lab, and it's pretty impressive. Every day you see new stuff. Every day we learn about products and different levels and different DPs for sure. So one of the other things I discussed with you before, Al, is the list of requirements when the clients come and they want to do Navs testing versus AAMA 450. So usually the clients, if you're testing for Navs and you want to put product together and cover products, different products, as you know, there's acceptance for Navs. There's others like outswing and inswing are not covered together in Navs, but we usually ask the clients for the drawing of the products, the sizes they want to test for sure. The class and the target DP is very important, since the class decide the gateway size. We usually ask the client to test the biggest to cover the smallest. So any bigger product will cover the smaller ones. So if you want a CW class, yes, you can test the gateway size, but if you're manufacturing bigger size, you have to test the bigger size that you will be manufacturing.
And that's a good point. Some manufacturers are under the impression that you just have to test the gateway size. But that's only true if the gateway size is bigger than what you normally build. Yeah. But if you normally build products that are larger than the gateway size, then you have to test that larger size, right?
Yeah.
So if your standard size, or if a lot of your sales are for products larger than the gateway size, you need to be testing those larger sizes, because the smaller, if you just test to the smaller gateway size, it will not apply to the larger ones. And I think that's something some manufacturers have not appreciated. And I think what you're referring to now is the consultation that you have with the manufacturer when they start talking about a test program, right?
Exactly, yeah.
So for example, if a manufacturer wants to test a product or a new product line, I guess you begin with some kind of an interview process where you ask them for information, like how much information do you want them to bring? Like, to get the most value out of the test program, what are the questions you're going to ask them?
Exactly. So these are the main things we asked. We also ask about the reason of testing, since a lot of time the architects want to, or like, put in their specifications, I want AW products, DP70 or DP100 for products that needs to be CW50, for example. So knowing the reason of testing and knowing exactly the target of the client, the class, the sizes they manufacture, get the drawing, get all the information possible. This way we help the client better, and we can combine and do the minimum tests possible. Same thing with AAMA 450. We ask the clients, if it's a new product, then it has to be tested for sure. But if it's a new combination, that we ask for the reports of the single units So these units are usually tested before. Let's give an example of a fix and a casement that was tested, and now the manufacturer wanted to put them together with the mullion to have this combination. Then we will ask for the reports of the single units. We will ask for the drawings for sure of the product and the combination of the product, the CAD drawing to do the analysis and all the calculation. We need the ratio 1-to-1 CAD drawings. That helps a lot, especially 1-to-1 is very important, since it makes a huge difference. That facilitates our life when it's already 1-to-1. The possible combination the client wants: ribbon windows, horizontal with vertical, with transom, no transom, double transom, divided in two, and if a test is available or not, if they already tested their combination before or not. So we gather this information, we put all this together, and from there I can combine and group as many as I can. And from there, I advise the client to test the weakest option and the biggest option too.
So this is something that I think in speaking with you earlier, and I think just in my own experience, is that some manufacturers come to the lab with a minimum amount of information, and they have I just want the basic test report, right, for my product. And I think sometimes they don't understand that maybe it's a better way to come to the lab and say, look, here's my whole product line. I sell my products mulled together this way, and I mull them together this way. I have all these different operating types. I have all these different options. How can I cover most of these possible combinations with the minimum amount of tests? And I guess that's the kind of service you can help, is if they can present to you with as much information as possible about the range of options they have, and the different reinforcing options, the different ways they mold them together, and the different sizes, their largest sizes, their smaller sizes. The more information you have, you're probably able to use the grouping rules in AAMA 450 to simplify. And when you talk about identifying the weakest configuration, basically, by looking at the whole range of products options they have, you can then show them how to group it so you can get a minimum number of tests that will cover all of those combinations. Is that right?
Exactly.
So it's not helpful if they don't tell you all the reinforcing options. It's not helpful if they forget to tell you that there's a double hung option that also gets mulled to the fixed window, not just the casement. Because if you knew that in advance, you might recommend, well, then let's test with the double hung, because that's going to be the weakest one, and then we'll, qualify the others. Is that kind of where what you do?
Yeah, exactly. So the more information we get, the more we can, the more the client will get in return. Since at the beginning, when the client decides to test a line of product or combine a line of product, for sure they can always come back and ask us to combine or add something to what was calculated and what was tested, but it might not get the same return as having everything from the beginning. Since when you will test at the beginning, the weakest option, let's say, if we take the example of one mullion, same mullion, but you connect to it a casement, a hung, a double hung, a fixed, which is 4 different product lines, then we will analyze which one is the weakest option, and from there we can test the weakest combination, and we can cover all other combinations. For sure, we're here. The client can always come back anytime they want to do extra testing or add extra combinations, and they're more than welcome for sure for that. But for a specific test, yes, the more information we have, the better we can help our clients.
I wonder if sometimes manufacturers are afraid to show everything they can, all their options, because they might be afraid then you're going to tell them they have to test more and more and more and more, and they'll run out of money. But I think what your analysis can do is to show, okay, if that's your whole range, here's what we have to test. But if the manufacturers look, that's too much for my budget right now, you can help them to choose, well, what will give you the most value, right? Because you could say, that's fine. I understand you just want to cover, you have a budget for this much testing. So this is here's the best option to get you the most coverage with your budget. And then at least now you know what's covered and what isn't. And in the future, if you're going to do more testing, now you know what you're going to have to test. And it really, I think it helps a manufacturer to have a plan for long-term management of the testing of their products, because over the long term, with that kind of a plan, they'll get much more value out of their test program than if they just come to you with a minimum amount of information.
And we can set priorities with the client. So we know that the client, for now, they're interested to cover this section or this combination now, and they know that in the future they might add this to their line or add more product types to the line, to the combination. But if the new or added product is weaker than what was tested, then we cannot go back. We have to start testing. But from the beginning, you might have a combination of a casement and in the future you want to do a hung, and your hung is like weaker than the casement, then for now we will test the hung and you will have your casement covered, which is better for you on the long run. You won't have to do extra tests in the future. But not telling us that from the beginning might result that you will have to do 2 tests instead of 1 test, for example.
Right. Yeah. So what is there a difference in approach to qualifying mullions through a Navs test as opposed to AAMA 450?
Yeah, so what we do as AAMA 450, there's 3 options as we all know. So the first option is testing the assembly itself, testing the whole assembly. We create a report for the assembly. So usually the products are covered, which again, it will be our standard example. It's a casement with a fix. So the fix has to be covered by Navs, and the casement has to be covered too, separately. These product has to be tested to the gateway size, has to be tested and covered completely. And then we have to test them separately, do the air and water test. This is required by AAMA 450. But as a lab, we always do the air, water, and structural, since all our calculations are based on tests. We cannot just base everything on calculation, because it's different liabilities. It's more of a consulting, so that we base all our calculations on physical tests that we do in the lab. Therefore, we don't stop at air and water only. We go and push also do the structural test. There's the second option, which is Mullion test. So if you have different type of Mullions, different reinforcement, then in this case, we test the Mullion. We get the Mullions, we put loads on the Mullion. There's a specific test to it. We get the different EI by test the modulus of elasticity and the moment of inertia through a load test on the Mullions. And the third option is calculation, purely calculation. But you have to always do the air and water test. This is a requirement. So
right now we're talking about just the Mullion itself, right?
Yeah. So the second option is just the Mullion itself.
Just the Mullion. So the Mullion could be, for example, 2 frames that normally join together.
Yeah.
When you mold 2 windows together. So would you just take 2 frame profiles and consider them as a single Mullion in the test?
Yeah, exactly. So
okay.
So we take the Mullion.
And this would be a beam test, is that right?
Exactly. This is
so you would put the 2 frames on a a test platform and you put a load on it
using
and you
a
make
transom.
reflections, right?
We use an instrument to put the load on the different type of mullions with different reinforcement, and we measure the deflection. From there, we can get the EI, and we do our calculations. It's not the most accurate way, especially with aluminum. Mullions usually slide because they're not anchored to frames. They're not anchored to test box. So it's not the most accurate way of doing it. Calculation and physical test are more accurate, but we still do it to have all the options and compare our options before taking a decision. If the manufacturer have different reinforcement for one specific mullion, we would test the weakest, which is no reinforcement, and this will be tested as a full assembly. We will have a report for this product, a Navs report covering the whole product with a non-reinforced mullion. Then we will do the mullion test, and we will do the calculation with all types of reinforcement, and we will cover all type of reinforcements. The reason.
So this is very interesting. So in other words, a manufacturer can come to you with, we're talking about the fixed encasement example, and with just testing the unreinforced gives you a Navs test report, and it gives you structural air and water ratings for the whole assembly.
Yep. And
the air and water rating of that assembly can be the air and water rating of the actual mullion joint, right?
Yeah, exactly.
And then now by doing the beam test of the other mullion options, which would be with maybe reinforcements. So if they have reinforcing options, you would then do the beam test with the reinforcing options. Would you also do a beam test with the weakest condition too?
Yes.
Just to compare with what was actually tested.
Yeah,
the whole product, right?
We have to do them all. So we cover all of them, even the non-reinforced, just to have all the data and properly compare the different options of reinforcement.
Right.
Just to stress on the air.
Yeah.
The air and water. If the water level is capped at, let's say, 400 pascals, for example, all the tables and calculation afterwards will be capped to this water level, and that's the reason that the air and water test has to be done on the assembly for all options.
So are you saying that you can't engineer the mullion for a load higher than 400 pascals?
We can for sure, but from the Navs perspective, we will have it in the table. It will be in red for the client to know structurally it can reach this, but for the water test, it cannot go higher than this level, for example, DP40. So your Navs report in general for any size will still be capped at DP40. Structurally, it can be strong, but water level, because for Navs, you take the weakest, either the water or the structure.
Correct. Yes. So if we're talking about the performance grade, in other words, the highest level of water penetration resistance might be limiting the performance grade you can get from your stronger mullion. Because if the performance grade, let's say the mullion is good enough for, PG80, but your water test level, failed at PG45, then you will never be able to label that product at higher than PG45, even though the mullion could go to PG80. Structurally, it wouldn't have the water penetration resistance required for PG80. Got it.
Exactly.
Yeah.
So general examples of grouping that we see all the time, there is for sure different manufacturer has different hardware, different products, different combinations. So each case is different than the other. But in general, what we see in grouping, and the majority of the manufacturer can think of that for their benefit, is mainly having the same mullion for different products. So we talked about that. If you have a fixed product, a casement product, and a hung product, for example, and you want to do different combination with these products, and it's exactly the same mullion, then we can for sure analyze, see the weakest option, and from there, the weakest combination. For example, we'll do the hung with the fixed, we'll test it, and from there we can cover all the other combinations. We check the sizes possible for the casement, the hung, and the fixed, and we'll take the biggest sizes, biggest combination, and from there we'll generate our tables to cover all the other options. There is also same mullion, different product types, so different product series. Let's say a manufacturer has two type of casement, and there is a weaker type or weaker model of casement than this. Using our calculations or the test results from the two products, we can compare the two products, see the weaker, then we'll take it, test it with the mullion, and from there we generate the tables and letter to cover the two type of casement series.
So this is something that is, I think manufacturers in Canada would have liked to know about when Navs first came into the code, because we weren't aware of AAMA 450 at the beginning, and people just felt they had to test all these different product options, and it was very frustrating and getting very expensive. And what AAMA 450 has within it is it has clear rules about how an engineer can look at that whole range of products and find out what's the minimum we need to test to get the most value. And I think that's such an important part of the value of the service that labs like yours are offering with respect to AAMA 450 is, I think it's of huge value. And I think any manufacturer looking at, a new product line, or any additional testing to their existing product lines should really have a conversation with the lab about the use of AAMA 450 and how can I just get the most value out of this next test program, because it's possible that you may get more bang for your buck, using AAMA 450 than if you were not aware of it.
Yeah, exactly. Another type of grouping we also covered is the same mullion with different reinforcement. This is
yes.
Usually a very famous grouping request that we get all the time. And this is majority of the time is the case. The manufacturer want to know their product's performance when they have different type of reinforcement. There's flat bars or U-shaped steel reinforcement, wood reinforcement. You have so many type of reinforcement, but you can't cover them all by testing. You will spend a lot of money just testing each product. So by doing, as I mentioned, the 3 steps, testing the weakest assembly, then we test all the type of mullions and do the calculations for all the reinforcement. We have all the possible data to give you tables covering all the reinforcement with all the sizes that you will manufacture in the future. And also we have the T-shaped mullions. This is a very famous grouping. When a manufacturer has a vertical mullion usually used and the transom come in action, then we test the product with the transom to cover the products without transom. And with our calculations, I'll show you that in a bit, an example of tables. We see that we calculate the whole product with the transom for the horizontal mullion, and then for the vertical mullion, we take the transom out of the equation and we do the calculation on the vertical product only.
I think it'd be very interesting to show our viewers examples of of that, because it's such a helpful thing to have to be able to see the various tables that you can generate using AAMA 450 from a single test in some cases.
Sure. First, I'll share my screen, Stefan, now to show a sample of report. So I created just a report sample of Navs in general. So in our reports, we have the address of the manufacturer for sure. Then the product type, Navs product type, when here we have a combination. If it's an operable with a fixed, the operable always govern as a product type. If we have two operable, the biggest operable governs as a product type for Navs. Then we have the primary designator with the class R, LC, CW, or AW. With the PG, the size was tested, the product type. Then we have the structural level, the water level, and the air level. If there's different options with reinforcement, without reinforcement, we have the table is expanded, and we have two primary designator, or two options, one with reinforcement and one with without reinforcement. When the description of the specimen, we add the model. Let's say if it's a fixed and a casement, then we have the product type is casement. The operable, is it outswing, inswing? We add all the drawings needed. Then the date of sample, we receive the samples, the date of testing. If it took 1 day of testing, it took 10 days, we write specific days of testing. Here, if there's any modification to the product, it's marked, and we identify what was the changes later. This part is very important. It's the anchoring of the product. So we have to explain exactly how the product was anchored, and it makes a huge difference. Is it anchored to a metal test buck or a wooden test buck? If it's a wooden test buck, how big was it? The gap between the product and the wooden test buck, the fasteners, how many screws, where they are installed exactly. All this information is very, very important, since the weakest also cover the strongest. And for the fasteners, you can for sure do calculations if you for anchors in the future, but as a lab, we stick to what is tested. Us personally, we cannot calculate the anchors, but we always take the weakest scenario, and this is described here. Then the combination assembly description, we describe how is it combined together, if there's couplers, how many screws, attaching the product together, attaching the mullion, if there's reinforcement, what type of reinforcement. If there's drawings, that would be even better, we describe it. If there's sealant, we describe the sealant, and we put the overall dimension of the product. After that, we describe each frame separately. So I kept it as our example, a fixed and a casement. And for a fixed, we see here, there's a missing section, but anyways, it won't change much for our presentation. But for a fixed, we describe, is it a PVC, aluminum, what is the material, how is it joined together, if there's reinforcement of the frame itself, the weather stripping, the sealant, the drainage, for sure glazing. So this is what I wanted to do. I'll just put the glazing here, because so with the fixed, we go through the glazing. The frame, the glass is always attached to the frame right away. So we describe the glazing, and we have the thickness of the glass, the air space, the type of glass, if it's tempered, annealed, it makes a huge difference. Again, the weakest glass cover the strongest glass. The smaller as thickness covered the bigger ones. So we describe the filling of the gas, the retention. We go through the glazing in general. We describe each frame separately and then each sash separately. The hardware, it's very important for each product where the hardwares are located, what are the type of hardware used, the manufacturer, the series of this hardware. All this makes a huge impact on the product, so we have to describe that in details. We usually get a bill of material with the description of all the products with their manufacturers and the serial number of this hardware, and everything is in the report. As I mentioned, the alteration, we usually come and write if keepers were changed, sealant were added, and everything is mentioned there. Then we come with the results. We add the air, water results, structural tests. This is water and structural tests, and the auxiliary tests afterwards. The reason any combination is covered through this report, usually we don't repeat the auxiliary tests, so we don't repeat the force entry and the auxiliary tests since they are tested separately, these products, unless it's bigger. The combination that we're testing is bigger. In that case, we will have to redo the auxiliary test. But the majority of the time, when the client is testing the single product or the product separately, they know that their biggest size is X by Y by X, let's say, then the assembly won't be bigger than that. The assembly usually is the same size or smaller. Yeah, that's the report. I'll stop sharing, Stefan, and I'll go. Yeah, if you have any questions or any comments about the report.
Well, now I think you were also going to show us the kind of tables that are generated for the Mullions as well, right?
Yeah, exactly. So
this is a combination assembly report. Would the tables that you generate for the Mullions be part of the combination assembly report or a separate report?
It's not a report. It's tables related to this report. So
okay.
I'll share an example of tables here.
Are you sharing your screen again?
Yeah.
Okay.
We're good to go.
Great, thank you. So here this is an example of a table. I kept it as Excel just to be more flexible and show you. Usually this is sent as a PDF for the client. And I removed all the client information, but as you can see here, test report, we describe this table is related to which test report exactly, and they are added together. Here you have the Mullion spans, so this is the product tested. We have two fixed with a transom in this case. So we're generating 3 reports, one for the whole combination, one for the horizontal mullion separately, and one for the vertical mullion. With these tables, and for sure we have a screenshot of the mullion to show the reinforcement, to show the product and the detail of the product, to make sure that everything is explained and clear on the table. Here we have all the Mullion spans until the maximum size tested and the tributary width of the product. So let's say if the client has a smaller product, they want to label, they want to cover, let's say it's an 8 feet by 8 feet. So they'll come here and then they'll have the rating of 40, but when it was tested, the product did 25.
So the limit of this table is the largest size and the lowest rating. Is that right?
Yeah, exactly.
And then for any width or height in between, this table can give you what the performance grade would be at smaller sizes.
Exactly.
So this is really useful now. And can manufacturers use these ratings for their product labels?
Yeah, exactly. So using these tables, you can use it for the labeling of the product, which helps a lot. You don't need to test each and every product and each and every size. You just have to test the weakest option, and from there you can have all the other sizes, the smaller sizes. We'll cover the pros, not pros, like we will cover mostly all the type of product using these tables. So I will generate a table for R and LC classification. As you can see, this is a product just R and LC. So we don't take into consideration the L over 175. But I also generate a table with the limit of L over 175 to make sure that we have a table for CW classification also.
So this product actually, so this product would have been tested as a R or LC, but are you saying that with a stronger reinforced mullion, it could achieve a CW?
So this was just an example. I didn't have the CW table, but usually these products are tested for CW.
Okay.
And after that, we put the limit for CW, and then we continue afterwards with the data. So we have a table for CW for the client, and then we have another table for R and LC.
Wow, so that's a lot of coverage, right?
Yeah.
So yeah, you've tested to L over 175, and now you have tables for those for the CW class. You keep testing with higher deflection until failure, and now you have additional tables for the same product at R and LC classes at larger sizes than you covered under CW. Is that right?
Yeah, exactly. And we can still generate tables with the limit of CW. Let's say we tested for CW with calculation, we can still generate the table for R and LC, but you don't get the best results. Once we test it until the limit, we know the deflection exactly. From there, we generate better tables for the clients and better coverage. But again, we can still generate the RNC classification tables, even though if we stop at the CW ratings.
So this is interesting. So the lowest performance grade here was PG25, which would be the performance at the largest size, right?
Yeah, exactly.
And under Navs, you would just be able to, for the smaller sizes, you would still be only able to label PG25 if you didn't have the AAMA 450, correct?
Yeah, exactly.
So basically, under Navs, if we zoom up to that configuration on the left, you scroll to the top of the page, and zoom into that window. So under Navs, just show the window, yeah. So under Navs, you tested that window, you got PG25, and even if you make smaller version of that product, you can only label it as PG25. But with the AAMA 450, you can actually report the higher strength, the higher performance grade it would have at smaller sizes.
Which is beneficial because
which is huge, yes. Yeah, that's really, the value that the AAMA 450 approach gives you. In addition to the grouping, it lets you get those higher performance ratings at the smaller sizes of the mullion. That's very, very, very useful.
So if you combine all the information together and you think about it, you cover a lot of sizes, a lot of combinations. You cover so many things without really paying as much as you would think that you will test each product, and you don't need to test each product. You don't need to each combination that you will do that you have to test it. And I completely understand it will be ridiculous. You will pay so much money, and this is where AAMA 450 comes and help all manufacturers and help the industry to cover these combinations, the product types, different product types. So yeah, it's very, very beneficial for everyone.
So, so some manufacturers might be wondering, is this going to be very expensive to generate this AAMA 450 report on top of just the cost of the Navs test? In other words, is this going to cost me twice as much or 3 times as much as my Navs test did? Just relatively speaking, is it expensive to have this additional AAMA 450, work done? When you're testing a product at the lab, is this adding a lot of cost to the manufacturer?
It's actually, first I'll stop sharing just for Stefan. So this is a very good question. And in reality, it doesn't cost as a test. In all cases, we have to test the air-water structural for the combination assembly. But as the tables, it costs around 20 to 25% of a full test. But you get way more because you get all the dimensions possible, you get all your combination possible, and the price is even relatively so small. So it's about 20 to 25%.
So basically, it's definitely a worthwhile addition, I think, for the manufacturer to consider, that you get all this extra value out of the process. So that's very, very exciting.
So actually, guys, we do have a couple questions. So if you want, I could move to that.
Yeah,
certainly. Yeah.
Okay. So, I'll use the occasion to let you guys know that we've been streaming live on YouTube for a couple weeks now. So we do have people watching on YouTube at the same time. So Steve, who's on YouTube, Steve Nason, was just saying hi, and he added a comment to saying that manufacturers use this table that you just show to show compliance for their mullions. Is that correct?
Yes.
Yeah.
Exactly.
Okay. Perfect.
No, but I think just to clarify, the manufacturer doesn't have to show. The manufacturer can actually use this table for labeling product, right?
Yeah.
Yeah.
So this is the thing. You don't have to show a building official your table.
Mm-hmm.
Basically, when you have these tables, you can just label the products with the ratings that are permitted with the test report, and the tables give you a basis for labeling the product on its own. And so somebody who looks at the label doesn't know if it was generated using just a Navs test or Navs plus AAMA 450, but the ratings are legitimate if the AAMA 450 report and the Navs test report actually exist.
Mm-hmm. Okay, so we do have a couple more questions here. So we have Dave Goldsmith asking, how are these tables used by manufacturers at order entry and for label generation? Is it manual or automated via software?
So I'm not very familiar with the manufacturing process of labeling.
Okay.
So I can let Al answer this question. He's more familiar with the labeling standards. I know the different options of labeling. There is 4 options of labeling. You can label the product separately, and the Mullion, you can label the whole product, but I'll let Al help me with that.
Well, I think I'm sure this is a question Dave Goldsmith has done a lot of thinking of, but once the manufacturer has these ratings, clearly they can use them for labeling the product. But that's a good question. I do you do that manually, or can you build that into your IT system?
I don't see why
entry and labeling. So
yeah, I don't see why you couldn't. Like, I mean, it's all data that's in a kind of an Excel sheet, right? So there's probably softwares that do work.
So
with that.
I think clearly, having the data gives you the basis for automating it for labeling.
Yeah.
But I think that would depend on the size of the company. In some organizations, smaller companies, there's probably more manual work involved here. In larger operations, you would probably have, you would want to automate this process. But I think it's really up to the manufacturer to figure out what's the most efficient way to do that. The important thing is that this data actually exists, so that
it would be interesting to know if anyone, like on the call or in the future, like maybe someone's doing it right now, right? So for the benefit of everyone, if someone wants to share.
Yeah, if anyone wants to offer their comments on that, we'd be happy to hear them.
Great.
Yeah, I'll take note of that and.
Maybe you go and find the answer.
Yeah.
Okay, so next question we have Steve Graham here saying, basically asking, the table is for fixed units, as what you can see. So can an operator be used with this report?
Yeah. This was just an example. So different type of products has different locking system, and this is considered in our calculations. So where the keepers are, where the loading points of hardware, this will be shown on the report. So the example was just a fixed, but each product is different than the other, as I mentioned, and each table will picture that, and you even in your picture of the product you will see the points of hardware and points of load of this product.
Okay.
So in other words, if for the fixed product you're probably getting the highest possible rating, because usually fixed products perform better than operable, at higher pressures. So if you had the a fixed casement option table, you would probably be limited in your design pressures by the performance of the casement product, for example, right?
Yeah, exactly.
So basically, you can't go higher than the highest load that casement actually sustained during the casement test at its largest size.
Exactly, and this is also seen when we do the structural test on the assembly. Usually the casement, or it depends, the mullion, but it will never go higher than what was tested as a separate casement. With the assembly, it becomes even weaker sometimes, and you can have the same failure. Let's say a keeper breaks during the single unit test, and we can see that reoccurring again when we do the assembly test. So it will never go higher for sure from the casement test.
Okay. We have Adam S. Asking, AAMA 450 is only for mullions, correct? Can't we can't use AAMA 450 to calculate a label and label the smaller size single casement, for example? That would require a full Navs test, right?
Yes. Okay. So back in the days, there was WDMA 2502, but now it doesn't really apply to that. The only product that we can test and go bigger is the fixed windows. We do the calculation for WDMA IS 11 2013, and this is for fixed product only, where we can test a size and even calculate up to 170% bigger in width and height, up to 200 maximum of surface area.
Okay.
So that's very interesting, because up until now we're just talking about AAMA 450, and it was my plan to further on in this series explore the AAMA 2502 standard and the WDMA IS 11. So your lab is actually offering calculations using these methods as well?
Yes, we do that too. So we cover.
That's I think it'll be worth having another show on those standards, because that gives us even more flexibility to introduce engineering into the to kind of expand the envelope of what you can qualify with Navs testing. So we might have to have you back, Tarek, on a future show to talk about that, because I think, you know, that's part of the arsenal. This is where the test labs and engineers can help manufacturers get even more value out of their Navs testing by using these additional standards. And this is why we're discussing them in this series. So I'm happy to hear you're working with those standards as well.
Awesome. Well, I mean, he did say that he was really happy to be on, and he was a fan of the show. So I guess, Tarek, we don't want to twist your arm, but I guess
I'll be happy to do that.
we do have another question from Dave. Are you using software to generate the tables? If so, what is the calculation method? Is it formula driven using AAMA 450 or something more sophisticated?
No, we have our internal software that we worked on just to facilitate our work, but regular calculations for AAMA 450, even Excel sheet at the beginning, it was all Excel sheet calculations. It's more complicated if we go into the standard, how to do specifically the calculations. But yeah, every engineer reading the standard in details can generate an Excel sheet that do this calculation. So yeah.
Okay.
That's it.
So, but I guess the answer to the question is that you are using the AAMA 450 formulas to, well, I guess AAMA 450 doesn't have the formulas. I think they're in another document, are they?
Yeah, well, when we generated the internal software, it helped a lot to facilitate and accelerate our process. At a certain time, I think back in the days, they was offered for the public, but before UL, but now we're not allowed to sell or promote or sell this software. So it's more internal use, but it can always be created. And once you read the standard in details with the formulas and you know behind the standard, yes, you can do these calculations.
Mm-hmm. Okay, well, that's the end of the questions right now, and I think anyway we're at the top of the hour here. I don't know if you guys had anything else to add.
There's one more thing I'd like Tarek to address, and that is, you know, AAMA 450 allows an engineer to do AAMA 450 reports as well as test labs. And Tarek, could you comment on what might be different between what a lab can do under AAMA 450 and what an engineer can do who is independent of a test lab?
Sure. As a lab, we are always restricted when it comes to calculation to what was tested. So we always base our calculation on tests, which is not a bad thing, since usually test gives you better results than purely calculation. So yes, you are limited to what is tested, but it's usually more performing. The products are more performing. We cannot, as a lab, do anchor testing, which is, let's say you have a product not reinforced, you add a specific type of anchors, and you want to go for reinforced mullions, then we will be limited to what was tested. And an engineer, on the other hand, can do the calculations for the anchors and push more the limit of anchoring. Another thing is we usually have the data. We don't need to analyze the data of testing or analyze all the documents or we don't charge you for that, which is a good thing, since we just add the table, since we have the data of testing and we base our calculation on it. So usually I think the charges are less specifically for the tables. We can always come back to generate more tables related to this product, different combination. If the client has a specific project with different combination or new combinations and they want to reach specific levels, then we can always offer this analysis. So yeah, the calculations are usually more, when it comes to the engineering side, is more conservative, but they are allowed to do more and go beyond what was tested by using calculations only.
So if I could rephrase what you've said, just to make sure I've understood it. So for example, when you test the full mullion assembly, and let's say in this example, it was a fixed and a casement product, then you test at the highest load you tested during that test is going to be the highest load for which the anchoring of that mullion is rated in the lab, right?
Mm-hmm. Yep.
So when you do the beam test and you can qualify the mullion, a stiffer mullion, but basically the overall pressure, you will be limited in the performance grade you can assign by the tested anchor load.
Exactly.
Right?
Yeah.
So you tested an unreinforced product, and that's where that gave the baseline of your anchor capacity. And so all of your subsequent analysis is limited to that anchor capacity that you tested.
Exactly.
And I guess an engineer could, by engineering, say, well, this engineering has a stronger moment of inertia. If I improve the anchoring, I could give this product an even higher rating. And the engineer is allowed to do the calculations to validate that stronger anchoring method and potentially give you a higher rating for that product. And the engineer, of course, is doing this as a professional designer, and so the engineers have a broader scope than the lab does. But as you pointed out, often the engineering assumptions are very conservative. So the engineers might actually have determined what you tested to the engineer. He might have assigned a lower pressure to that same anchoring method based on calculations which are conservative. You're basing it on what was actually tested. So there's pros and cons. But I think basically there are some differences like that between getting AAMA 450 done by an engineer versus a lab. But in all cases, you need testing for air and water for the mullion joint, and so there's basically two ways to go about doing this. It's possible, though, that the engineer, because they're relying more on calculations, the engineering work will have a different, we don't know yet because we haven't spoken to an engineer about this, but the engineering route, may have a different cost factor as well, because it's based on, completely different, well, not completely different, but in other words, the engineer will be spending a lot more time doing calculations maybe than you guys do, because you're working from tested values and working from that as a database. But I thought it was good for our people on this call to appreciate that AAMA 450 allows engineers to generate these reports as well, not just test labs.
Okay.
And so, I think I just want people to be aware that there's another option here as well. Sure. And I think we have one more question. Is that right,
Yeah,
Steph?
there's one more question that came in, so I think we can answer that. So Dave Goldsmith's asking, how are you determining the flexural rigidity of the mullion? Is it by testing or calculation?
Well, by both. As I said, all what we do is based on the testing. All our calculation is based on testing. So if we just test the full assembly, we would use the deflection and the design pressure of the assembly to generate our tables and do our calculations. And from there, we get the moment of inertia of the product, we get the modulus of elasticity, the shear, we compare If we do also the Mullion test, then we have more data if it's different type of Mullions, and from there we generate our tables. So it's all together basically. We use all the data as a lab. We have to always base it on what we tested. So this is how we work usually.
So basically you've got the Mullion data from the full product test of the combination assembly. And then if you do the beam test, which is a separate test you can do, you can also then, to qualify the other reinforced, the untested Mullion options, if they are just internal reinforcements within the same framing system, you can determine the moment of inertia with the beam test. Is that right?
Yeah, that's right.
Right.
And we do the calculations also. So we have all the data, but at the end, our table that we generate are limited and based on the deflection from the assembly test and the design pressure of the assembly test too.
Right. Right. Yeah.
Okay.
Well, thank you, Tarek. This was very interesting. I've been wanting to tackle this subject for years, and it just so happens that when I worked in a consulting firm, we never actually had clients that had requested this service, and when I was testing products, we didn't really know about these standards at the time. So I'm really happy that you could be with us today and help our viewers understand the new tools. Well, they're not new tools, but they're tools that have not been sufficiently appreciated, and we wanted to make this known to a wider audience and have more people take advantage of these options to get more value out of their Navs test program. So thank you very much for being with us today. We really appreciate you helping us understand what labs can do in this area, and I'm looking forward to. We'll see if we can work in another show dealing with the engineering option. But at this point, I don't have any engineering resources to draw from. And if there are engineers actually offering this service that would be willing to tell us about it, please get in touch with us, and we might be able to have another show talking more about that one. Yeah. But thank you very much, and we appreciate UL's support of the program as well. And over to you, Steph.
Well, that's pretty much it. So I'll just invite everyone to go have a look on our Facebook page to see this show and the previous shows. Just sign up on our the YouTube page, and you can click on the little there's a little bell icon there, so you'll get notified whenever we go live. So that's a good option too. But that's it, and thanks to our sponsors Quax and UL, and I guess see you all next week. Bye.
Thank you.
Bye.
Thank you.
Bye.
You are a member and want to be part of the live recording of Tech Talks? Easy. Visit fenestrationcanada.ca and sign up for the next show.